Hi guys, so in this video we'll be talking about expanding algebraic expressions. We'll be specifically discussing um, perfect squares and difference of perfect squares, so difference of two squares. So perfect squares. Uh, Perfect square number is the answer you get when you multiply a number by itself two times. So this expression a plus b in bracket squared is a perfect square because it's a term that is multiplying by itself two times. So the normal way of expanding brackets is um, you follow this distributive law up there. So if you have something outside of a bracket multiplying by everything inside the bracket, you see the bracket means multiplying, so a will be multiplied by b, and then a again will be multiplied by c. Whatever is outside the bracket, you multiply by everything inside the bracket, because the bracket is also a grouping symbol which groups b and c, and it's multiplying b and c with a outside. So a is like the common factor which you multiply by everything inside. Now if you have binomials like this, and by binomials I mean two terms in a bracket like a and b, they are binomial, and c and d, they are binomial, and also we are multiplying two brackets like two terms to get a product, binomial product. So again, bracket means multiplying, and bracket also mean grouping. So these two brackets mean a is multiplied by c and d, like the first case, and b is also multiplied by c and d. So as we expand, we'll get a times c, a times d, plus b times c, plus b times d. Okay, so let's look at how we expand brackets for perfect squares in a short way. Now if you expand it in a long way, you see a plus b squared means a plus b multiplying by itself two times, a plus b times a plus b. So when we expand, a will be multiplied by a, giving a squared. A times b gives ab. Um, okay, let's do it. So a plus a times a will give a squared. A times b is ab. Then b times a is ba in alphabetical order, ab. And b times b is b squared. And when we collect like terms, we'll have a squared. ab plus ab gives 2ab plus b squared. So we can look at this answer and we can just go shortcut by just playing around with a, b, and the power of 2 there. See, to go shortcut, we can just go a squared plus 2 times a times b plus b squared. And the same applies for a minus b squared. You can go a squared plus 2 times a times negative b, which gives negative 2ab, plus negative b squared, which gives a positive b squared. So let's see this example. We've got x plus 4 squared. Now to go short, we can just go x squared plus 2 times x times 4 or 2 times 4 times x, whichever way, gives positive 8x, and 4 squared gives positive 16. That's the shortest way to go. If we want to expand it in a long way, then of course we have to write x plus 4 squared in this manner. X plus 4 in bracket squared means x plus 4 multiplying by itself 2 times. So when we expand, we go x times x is x squared, x times 4 is positive 4x, 4 times x is positive 4x, and 4 times 4 is 16. And when we collect like terms in the middle, we'll have x squared plus 8x, for plus 4 is 8, 8x plus 16. So that's an example of a perfect square. Now let's see difference of perfect squares. Okay, this will come from when you expand brackets that contain conjugate pairs like this one. A plus b times a minus b. This pair is called a conjugate pair. It is made up of same terms a, b, but one bracket has a plus and one bracket has a minus. So if you have a conjugate pair multiplying, the answer in short form will be a difference of perfect squares. So you get the first term, you square it, get their difference, you minus the second term, squared. So a conjugate pair and expanded gives you a difference of perfect squares. And of course, you can do it the long way using the distributive law to prove check your answer. Let's see one example for difference of two squares. Alright, so here's one example of conjugate pairs multiplying. 2x plus 1 times 2x minus 1. Again, they are called conjugate because they have the same terms. 2x1, one pair has a plus and one bracket has a plus and the other bracket has a minus. So to go shortcut, the expanded expression will be 2x squared minus 1 squared. Difference of perfect squares. You get the first term, you square it. Of course, the first term we have a pronumeral and a coefficient, 2x. So we square both the number and the letter. And the second term is 1. It doesn't matter if you square the negative 1 or the positive 1. If you square the negative 1, you will still get the positive 1. If you square the positive 1, you still get the positive 1. Difference is the answer you get from subtracting. So the first term squared minus the second term squared. That gives 2 squared is a 4, x squared is an x squared, And 1 squared is a 1. And 1 is a square number which comes from 1 times 1. So you see the answer is a difference of perfect squares. 4 is a square number, x squared is a square number, and 1 is a square number, and they are subtracting. And if you want to do it normal long way using the distributive law, then it will be 2x times 2x, which gives 4x squared. 2x times negative 1 gives negative 2x. 1 times 2x gives positive 2x. And 1 times negative 1 gives negative 1. When we collect like terms, negative 2x plus 2x is at 0. And we are left with 4x squared minus 1, which is the same we did when we go shortcut. I hope this helps with expanding of brackets, especially to do with perfect squares and difference of perfect squares. That is all for now. After you watch, do like and subscribe, and see you in the next one. Bye.